Hello class, in today's lesson we are going to talk about solving polynomial equations, which is found in section 5-3, part 2 of your book. We're going to solve polynomial equations by factoring. So in example 2, it's supposed to say what are the real or imaginary solutions of each polynomial equation. So on the first one, what we need to do is we need to put everything in standard form. So in order to put everything in standard form, we need to subtract 4. So that's going to give us x to the fourth minus 3x squared minus 4 equal to 0. Now, at this point, we can't just take out a greatest common factor because there is no greatest common factor here. So it almost looks like we're at a standstill because we can't do quadratic formula, because in order to do quadratic formula, you have to be able to have the highest power be squared. So what we're going to do here is actually substitute a variable for x squared so that we can force this to be a quadratic equation. So what we're going to do is force a to equal x squared. So everywhere I see an x squared, I'm going to make it an a. So first of all, x to the fourth, remember, is x squared squared minus 3x squared minus 4 equal to 0. I'm writing it like that so that you can see that every place that is parentheses, I'm going to make an a. So now this becomes a squared minus 3a minus 4 equal to 0. That one now is in quadratic form, so now I can do AC. AC would give us -4, and the factors of -4 that would work are 1 and 4, specifically -4 and +1. I guess I'll go ahead and work out the steps. So that give me a squared plus a minus 4a minus 4 equal to 0. Group and group. Greatest common factor here is a. What's left over is a plus 1. For the other one is -4, and again it's still a plus 1. So the factors are a plus 1 and a minus 4 equal to 0. Now at this point, this is where we want to go back and substitute a as x squared. So let me rewrite that over here to the right. So that's going to be x squared plus 1 and x squared minus 4 equal to 0. So if I set each one of those equal to 0, that would be x squared plus 1 equal to 0 and x squared minus 4 equal to 0. If I subtract 1, that gives me x squared equal to -1. If I take the square root, x then becomes plus or minus I. Okay, on the other one, this one actually becomes difference of squares, right? That really becomes x plus 2 and x minus 2 equal to 0. And so those x's become plus or minus 2. So we are done. Okay, so that's how we deal with the first example. And so again, the first thing we need to realize is that it wasn't, the power was too high and there was no greatest common factor. So in that case, we need to substitute a variable for x squared. Okay, so I'm going to go ahead and erase this so that we can do the second problem. All right, in the next problem, we have x cubed equal to 1. So this is actually a new type of equation because now we're going to start talking about sum or difference of cubes. So actually, let me go ahead and put this in standard form. So if I subtract 1 on both sides, this becomes x cubed minus 1 equal to 0. So this is clearly a difference of cubes. And so what that formula says is that a cubed minus b cubed equals a minus b, times a squared plus ab plus b squared. That looks really confusing. So what this means is, in order to find what a is, it's the cubed root of that to give you a, and the cubed root of b cubed will give you b. So the cubed root, in other words, you're trying to say what times what times what will give you x cubed, that will be x, and what times what will give you 1, it's going to be 1. And so since this is a difference, subtraction, right, we will just follow this formula. So our answer will be x minus 1, right, for a minus b, times a squared, which would be x, so that becomes x squared, plus ab, so that just becomes x, plus b squared becomes 1, because that's 1 squared. And then at that point, the first one is pretty simple to set equal to 0, right? Because x minus 1, if I set that equal to 0, then we're done there. But the second one, we actually have to do quadratic formula. So we know one of our x is going to be 1 on that first factor. So I know this is really going to be x equals 1. So I'll just remember that until the end. And then remember, quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And we'll do that for the second factor here. So let's do that. X equals negative 1 plus or minus the square root of 1 squared minus 4 times 1 all over 2 times 1. That will give us negative 1 plus or minus the square root of 1 minus 4 over 2. That becomes negative 1 plus or minus the square root of negative 3 over 2. And that square root of negative 3, we really know is negative 1 plus or minus I square root of 3 over 2. So our answers are, our solutions, don't forget that this is a solution and this is a solution. So if I break those apart, my solutions are x equals 1. And then negative 1 plus I square root of 3 over 2. And the other one is negative 1 minus I square root of 3 over 2. And we are done. All right, there's a couple more examples on the next one. All right, so on try 2, we have quite a bit to do. So let's go ahead and get started with the first one. We have x to the 4th minus 16. Notice everything starts or seems to start when it is in standard form. So we need to subtract 16 first. So that becomes x to the 4th minus 16 equal to 0. At this point, once again, that x to the 4th is kind of giving us an indicator. Well, there is no greatest common factor, so we probably need to substitute. So we're going to substitute a as x squared. So remember, this is really x squared squared, right? Minus 16 equal to 0. So that's really a squared minus 16 equal to 0. We know what that really means, right? We know that that ends up being a difference of squares. So that becomes a plus 4 and a minus 4. Remember that a is really x squared, so this is where we go back to substitutes. That becomes x squared plus 4, and then x squared minus 4 equal to 0. Now, the second one is pretty easy to do. Not that one, but the second one actually ends up becoming x plus 2 and x minus 2, right? So we can easily find those x's. We know that's going to be negative 2, and we know that this one is going to be 2. But we need to go ahead and do quadratic formula. Actually, we don't have to do quadratic formula on that one. We can actually write it like this and then subtract 4. So x squared would equal negative 4. Take the square root. So x equals plus or minus 2i. So the solutions here are going to be plus or minus 2i and then plus or minus 2 from here. And we are done with the first problem. So again, on this problem, we realized that we had a 4th power and no greatest common factor, so we need to use substitution. All right, let's look at the second one. I need to erase this. All right, here we go. So on the next one, I need to subtract, oops, I'm going to go back to black. So subtract 2x squared. And I'm going to rewrite all this all the way to the right. So that makes x cubed minus 2x squared minus 8x equal to 0. On this one, we do have a greatest common factor, which is x. So we're going to take out an x, and we're left with x squared minus 2x minus 8 equal to 0. Okay, if I do AC, it'll give me negative 8. So it's 1 and 8, 2 and 4. And what will work is negative 4 and positive 2. So if I keep going, that would be x squared plus 2x minus 4x minus 8 equal to 0. Group and group. Take out an x, I'm left with x plus 2. Take out a negative 4, I'm still left with x plus 2. So that's x minus 4, x plus 2. set each one of those equal to 0. And so my factors will be x equals 0 for the first one, 4 for the second one, and -2 for the last one. Okay, and then the very last one, so the second one was actually pretty easy, pretty straightforward. That one had a greatest common factor, so we just took it out. And then the last one, we can go ahead and do that one now. So I need to erase once again. All right, so on the last one, if I subtract 3x squared, because again, it's all about putting it in standard form first, I would get x to the 4th minus 3x squared minus 10 equal to 0. Okay, there is no greatest common factor, and we have a 4th power, so that means we're going to use substitution. So that means I'm going to write a as x squared. So this becomes x squared squared. By the way, you can skip this step if you kind of already got the hang of it, but I'm just going to keep writing it just in case. So that really becomes a squared minus 3a minus 10 equal to 0. Okay, AC here is only 1 and 10 and 2 and 5. 2 and 5 will work, right? But it's going to be -5 and +2. So that becomes a squared plus 2a minus 5a minus 10 equal to 0. Group and group. That becomes a is greatest common factor, and then a plus 2 is left over. -5 is the greatest common factor, and then a plus 2 is still left over. So then your factors are a minus 5 and a plus 2 equal to 0. The a's now need to be substituted back, so that becomes x squared minus 5, and then x squared plus 2 equal to 0. Now at this point, I want to set each equal to 0, so I'll have x squared minus 5 equal to 0, and I'll have x squared plus 2 equal to 0. If I add 5 on both sides for this one, I get x squared equal to 5. Take the square root, so x equals plus or minus 5 for that one. If I subtract 2 on this one, I'll get x squared equal to -2, take the square root, and so then that one becomes plus or minus, there we go, plus or minus I square root of 2. And we are done. All right, so that's about 5 examples from this section. So I hope that kind of gets you guys in the right direction. If you have any questions, come see me for tutoring.